Hi, I am Rajiv Aunde. I am a director with Aditya Environmental Services Private Limited. We are a QCI and ABET accredited EIA consultancy organization based out of Mumbai, and we are mostly active in the western part of India, having offices in Maharashtra, Goa, and Gujarat. The topic I have been given is on assessing environmental impacts. That is to give a talk on the methodologies and the various aspects involved in assessing environmental impacts. So in this topic, what we are going to cover is first some initial slides on uh, environmental impacts, the characterization, the types of impacts, etc. Then we go towards aspects involved in assessing impacts on land environment, aspects involved in assessing impacts on air environment, aspects involved in assessing impacts on water environment, aspects involved in assessing impacts on biological environment, socio-economic environment, and then when as a final, when we have to summarize the impacts of a project, how do we summarize the environmental impacts of projects? That is the various metrics and evaluation systems which are in vogue for this purpose. So, as I understand, this course is on environmental impact assessment itself, and I believe other uh, uh, resource persons would have covered aspects, basic aspects on EIA, like what is the main key features of EIA studies are. One is to study project related environmental aspects, to study the baseline and to have a evaluation of the baseline environment, then to assess the impacts. Once we have knowledge about the project itself and its environmental aspects, the location of the project and its environmental setting, then we superimpose the impacts of the project on the baseline status and assess the impacts of the project. In fact, this is the most important component of the EIS study. In fact, the principal objective of doing a EIS study is to assess the environmental impacts of a developmental, to assess the environmental impacts and to formulate an environment management plan based upon the impacts which are derived. So, what are environmental impacts? As the dictionary meaning goes, an environmental impact is the effect that a people's actions have on the environment. It is defined as any change on the environment, whether adverse or beneficial, resulting from a facilities, products, activities, or services. However, when we are talking of EIA environmental impacts in the context of EIA notification of 2006 of the Government of India, this delves mostly on the environmental impacts from new projects or activities. So we will be looking at impacts from a perspective of new projects, activities, or the expansion and modernization of existing projects or activities. Now, these environmental impacts may be characterized in different ways. One is they may be characterized as adverse or beneficial, temporary, that is short term, or permanent, that is long term, reversible versus irreversible. That is, there are some impacts which are permanent and reverse and irreversible. So those are the impacts which we have to look at the most in a stringent way and try to see how we can rectify the situation. Then we may have localized impacts versus large or wide scale impacts. Like, construction projects typically have localized impacts, whereas large power plants, thermal power plants, which are like 800 megahertz or 400 megahertz, they have impacts which are spread over a very large scale. Then we have primary, secondary, and tertiary impacts. Primary impacts are those impacts which are directly resultant from the project or the activity, and secondary impacts and tertiary impacts, as the name suggests, are derived impacts. Like, for example, a direct impact of a thermal power plant would be the NOx generation from the thermal power plant, but when or the particulate generation. But the secondary or tertiary impacts may include formation of haze, or impacts on ground level ozone, etc. Now, impacts depend on the magnitude or the type of impacts. One thing which we have to understand is that impacts depend upon the type of project, that is the nature of the project, whether it is for example, if you have a coal-based thermal power plant, then the impacts which are the major environmental impacts are identified as those from air pollution, that is particulates, sulfur dioxide, nitrogen dioxide, etc., and solid waste due to fly ash generation, as well as disposal of high temperature effluent. The Whereas in case of a petrochemical or a cracker complex, the impacts will be mostly the generation of a large quantity of non-methane hydrocarbons and VOCs, which will require proper management, and the odors which result from that, which will require proper management. The Also, the effluent in this case will be having high organics, and it will be a polluted effluent. The hazardous waste, large quantity of hazardous waste will be generated in a petrochemical or a cracker complex. Now, if we talk of a highway or a greenfield airport project, the impacts are land use, biodiversity, and socio-economics. So, as you can see, the nature of the project very much dictates the types of components of the environment which will be, or the parameters in the environment which will be impacted. The second thing which is there is the nature of manufacturing process or activity. The meaning, in fact, you may have a power generation based upon coal, which will result in generation of particulate, sulfur dioxide, and nitrogen oxide, plus generation of huge amounts of fly ash. Whereas a power plant which is based upon natural gas may have a major pollutant is only NOx, nitrogen oxides. Similarly, if you have a solar power or a wind farm project, the impacts in those cases are more on the biodiversity and the land use, rather than on air pollution or solid waste generation. Thus, the environmental impacts depend upon the type of project and the nature of manufacturing process which is carried out. Then the impacts also depend upon the scale of the project. If you have a large greenfield project, then it will have substantially more impacts than the brownfield expansions. Similarly, small scale chemical industry will have projects which are will have impacts which are more on a localized scale, versus a large scale unit which will have impacts which are spread over a larger area. Then one other important concept here is that the project location. If you have a project which is located in industrial estates, it will have lower magnitude of impacts than the greenfield ones. And project near to protected areas like wildlife sanctuaries, national parks, etc., will have more severity of impacts. So depending upon the location, the impacts or the magnitude or the severity of the impacts changes. Projects which are located close to cities, for example, if you have a project coming up near to Delhi or near to Mumbai, even if it's a power project which is vital for the city of Delhi or Mumbai, it is going to result in a lot of a higher magnitude or a higher severity of impact than one which is coming up in an area which is about 100 kilometers from Delhi. So two terms which come up very significantly in this is, one is that impacts are site specific, and the second is that impacts are project specific. The how do you go about the process of identifying the impacted component? The critical aspect here is to study the manufacturing process and the aspects and activities involved in each or identify the components or in the different phases of the manufacturing in the project. This helps us to determine the type of impact which will be experienced, as well as the nature, whether it will be a adverse or a beneficial impact, and its severity, that is whether it will be a adverse, permanent or a temporary impact. For example, for a manufacturing unit which is to be established, a greenfield manufacturing unit which is to be established outside an industrial area, the impacts based the various activities have been identified in the table below. If you see, we have four principal phases of the project, namely construction of buildings and erection of plant, second is commissioning, third is operation, and fourth is closure and decommissioning. Now, what is this concept of closure and decommissioning? Here, what we are considering, that in case this unit has to stop, is to be stopped or has to close down for some reason, even those aspects, how it will do a safe closure, which will not result in an environmental impact, should be considered. Now, if you see these various project phases and identify the aspects and activities which are involved in the project phases, then you can make out what are the impacts which are generated, which will be generated, and the severity or the type of the impact, that is whether it's a adverse or negative impact. For example, in a during construction phase, there is not much of effluent discharge or air emission except for that from the construction activity, which is principally the dust which is generated from the construction activity. And the waste disposal is also mostly comprising the substratum which is removed from the land or from the demolition rubble or demolition waste, etc. So the impacts are mostly temporary in nature. The only positive impact is from the use of manpower. Whereas in the commissioning phase, you have discharges of wastewater or air emissions which are sudden, and many times your pollution control equipment may not be in a position to treat those effluents or the air discharges, because they are not fully stabilized. So in this case, the impact due to the project, yeah, we have identified, given the impact as of temporary nature, because it is only for the commissioning phase, which is supposed to be a very short duration phase. Whereas in case of a operation of a unit, the air emissions will be more of a continuous nature, and wastewater discharges will also be of a continuous nature, rather than the sudden discharges which we have experienced earlier. And in those cases, the impact will be mostly permanent, rather than uh, uh, as compared to the temporary impacts which we have seen in the construction and the commissioning phase. Now, coming to closure and decommissioning, the principal impact is due to the land pollution, which will be more or less because of the fact that this piece of manufacturing plant will become redundant and will be just lying around idle. And if it is not safely, if it is not made environmentally benign, then we may have problems of land pollution. In addition, we can even further go more into details in this, and uh, divide the various activities themselves into various sub activities to help us understand the nature of impacts much better. For example, in the construction phase, which we have seen earlier, construction of buildings and erection of plant, we had we can break it up into different sub activities like land clearance, cutting and filling, foundation excavation for the buildings which are to be constructed, cutting and filling for the leveling of the land which is to be for on which the manufacturing unit is to come up, then the operation of RMC plant, ready mix concrete plants, building construction, and sourcing of raw materials, which creates traffic in the nearby area. So in all these aspects, the various impacts, which are the principal impacts which are likely, can be identified by breaking the aspect or the activity into various sub activities in order to understand better the impacts from a likely components of environment which will be impacted from the proposed project. Now, as we saw earlier, in the various stages of environment EIA studies or in the preparation of the EIA report, we have two principal components. One is the which we have already been covered by some other resource persons, which are to study the project related environmental aspects and the baseline environmental studies. Now we are going towards the how to assess the to understand how to assess the impacts on the land environment. Now, what are the aspects of land environment which we cover during project related environmental studies or during the baseline environmental studies are during project related environmental studies, we consider the land requirement, the area breakup of the project, the type of activities to be taken up on the project land. In the baseline environmental studies, we evaluate the geographical setting, the topography and geographical setting in which that particular project is located, the topography and the contour levels of the site and the vicinity. Maybe for smaller projects, just the immediate vicinity is good enough. But for larger projects, we go up to 10 kilometers radius or 5-kilometer radius, depending upon the expanse of the project. Then we look at the drainage pattern, the land use land cover pattern, and the soil types in that area. This is how we have covered the aspects. These are the various aspects which are covered during the baseline environmental studies. Now, how do we assess the impacts from a project knowing this particular background? Now, first of all, we have to understand what is land pollution. Land pollution is the deterioration of Earth's land surface directly or indirectly by various human activities. Now, there are various degenerative actions which cause impacts on land environment. The most important and significance of that is land conversion and clearance. Land conversion. What does the term conversion mean? The term conversion means the conversion of a uh, fertile productive land like that from a agriculture to residential or agriculture to industrial or from a forest land to a non-forest land, maybe for mining. So in all this is covered under the term conversion. Now, because we have to cater to a very large human population which is ever increasing, we have to the state has to yield and give permissions for various projects to convert their available land into various non-productive uses. And this is one factor which causes the most significant impact on the land component. Now, once you convert a virgin land into a non productive application, like for example, if you convert a forest land into a mining area, you give a permission to start a mine there, then the proponent, first of all, he starts with clearance of the project. Clearance meaning he will first take up the land and decide what is the project he is going to come up with. Now, in this figure, we have shown the various activities which are to be which are taken up typically by proponents. In the figure to the right, the two figures to the right, we have a construction or a development project, which is the basic project, which we can say. Here we have a land area, a agricultural field, non-productive, being converted into a construction site. So the first aspect which we see is they are clearing the land, they are leveling it by putting earth from outside, or doing some cutting and filling, removing the vegetation from this site. Now the second one which we can see is the highway project to the left. Now, if you see the highway project, as we all like to go out in outings these days, we all like to go on vacations, but and we'll all like those beautiful swanky national highways which have come up, or the expressways which have come up. But if you think of the impacts which these projects have on environment, they are disastrous. For example, if you can see in the figure on the left, a highway project which when it cuts through a hill, a lot of cutting work is involved in making way for the highway project. Similarly, this cut material needs to be disposed of somewhere. Maybe a part of that has been used for filling up and making an embankment for the road on the downstream side. But this same embankment, if it is not properly planned, the cutting itself or the embankment is going to cause a lot of impacts on the hydrology of the area. We can see how this whole work involves large amount of earthwork, which needs to be properly and safely done in order to ensure that there are no impacts on the impacts on the environment can be reduced to a minimum extent. Now, what we see below are the two pictures of two open cast mines. Now, if you see the site on the left is the site on the left is an open cast mine, which is an active mine where we can see a number of trucks and dumpers which are there for which are trying to excavate and remove the mineral from the bottom of the pit which is created. But if you see the level of the top of the hillock to the point below, a lot of earthwork has been done, and site has been excavated to the level in order to remove the mineral from the ore body. And this will be then taken by single trucks on through these benches onto the top, where there will be a beneficiation plant or some other um, uh, cleaning mechanism whereby the ore will be cleaned physically, sometimes chemically for some ores, and then the remaining part of the ore, which is not the substratum which is removed along with the ore, which is not of any use, will have to be again disposed of. So a lot of lot of handling of earthwork is required in this whole process, and lot of cutting and filling is also involved in the process of trying to extract this iron ore. What we do is we cut the entire mountain top, we go down below. This whole excavated material has to be stored somewhere. If you notice here, there is an outside dump which has been mentioned. So we make a pit here and create a hillock somewhere else. So we totally change the hydrology, and sometimes even the hydrogeology, because there might be groundwater table which we'll encounter as we go mining deep into the pit. This figure on the right shows how a scar is left on the landscape once the mining activity is completed. Uh, this is another picture of a MTR mining, that is mountain top mining, which is done to remove the coal from the seams. And in this case, the coal seams are seen to be present on the hillock, which is covered with forests. But in order to quest the mankind's search for energy, we need to remove this coal and use it in our power plants to burn and generate power. So what is done is the vegetation is removed, and we reach the ore body. As we remove the vegetation, and remove the top surface. The material excavated, the mining spoils are disposed of into the valley, and they flood the uh, valley, thus again destroying the vegetation there, as also spoiling the stream which is there below. As we go from the top to the bottom, we have the final level of the land, as we can see, and the mining spoil has completely altered the topography and the hydrology of this area. So the uh, major impacts due to land clearance for mining, development of construction sites, industries, roads are the major causes are the urbanization, industrialization, and mining to cater to the rapid population growth. In this case, we have the effects which are caused are: one is the loss of natural soil cover, which is during land clearance and due to increase in soil erosion. We will have the topsoil which is rich in humus, and we need to this may be removed, which is means it's a great loss to the environment, because we are just throwing the soil rich in which can support the vegetation. Second is there will be changes in hydrology and natural drainage pattern, as we saw, which may be due to the changes in topography due to cutting, filling, or waste dumping. Then the waste in changes in hydrogeology, which we saw, deforestation or the loss of green cover. This may lead to disastrous effects like species extinction or loss of native species or biomagnification. Mining near Western Ghats in areas like in Karnataka and in Goa has caused a lot of damage to the Western Ghats. Then we all these project land clearance may lead to desertification, that is major drying of land and degradation of land, making it unable to support life in future. Cutting and filling, as we have seen, the excess cut material needs to be properly disposed of, and the fill material, if the fill material requirement is high, then we need to source this fill material from outside. So again, this requires a lot of planning. Then although the impact, there will be impacts on climate due to reduction in rainfall, since the green cover reduces. There will be traffic generation and impacts on the social structure. The major impact of all these activities is that the land is made unavailable for productive uses and affects the entire ecosystem of that area. Then the second major factor which affects land environment is waste disposal, which is basically because of dumping of solid and hazardous waste. We are all seeing these scenes all through the country, whether it may be Delhi or Mumbai, and the municipal solid waste pile is a known feature on the landscape now. Uh, in Mumbai, we have the dumps which are created near mangroves, which has eaten up a lot of space within the mangrove, fertile mangrove land. And you can see a lot of fires which are burning here, which is causing a lot of haze, which is what we have seen in Delhi, happening in Delhi. Then hazardous waste stockpiles, which may result in leaching of chemicals and metals onto toxic chemicals and metals onto soil and land, and may affect the quality of the soil. It may contaminate the soil. It may change the hydrology and the natural drainage pattern. There may be breeding of vectors, particularly so in case of MSW dumps. And then we may have effects on biodiversity, then poisoning through gaseous fumes and smoke, etc. Which are the projects which have maximum impact on the land environment? The projects, these include mining, highway and railways, greenfield airport projects or port projects, large area developments like that of a township, golf course, etc. Large area developments like industrial estates, parks, SEZs, etc. So how do we assess the impacts on land environment? The whatever are the physical attributes are can be computed now. We have techniques available, we have technology available to identify the physical attributes. By what physical attributes? Some of them may mean, one is estimating the cut and fill volumes. Now if you have, it is very essential from a perspective of planning. If we, for example, we have a land surface which needs to be cut and leveled, there may be some cutting and filling required. Then there are techniques available by using either drone survey or plane table survey, estimating the topography and contours of the entire site. And then using softwares like AutoCAD and GIS, we can find out the exact quantity of cut and fill volume, and ensure that this, knowing the, we can even study some amount of of the site which is beyond the particular site area, so as to ensure that the natural drainage pattern will be changed to the minimum. This is done by so then we have, for estimating the the quantity of water flowing, we can delineate various micro watersheds and landforms, and we have to study the various watersheds and the micro, and then based on the contour levels or the digital elevation models, and then using GIS software and rainfall data, we can compute the water quantity which is falling over the micro watershed. This quantity of water, if suppose our project is coming up in any of these micro watersheds like micro watershed 1 or 2, and it's right in the, so we can compute what is the water, the extent of water which will come from the upstream and which needs to be safely sent to the downstream side, and there is no loss to the downstream users because of the project itself, or there is no flooding due to a physical barrier being created. Then we have techniques to assess the rainwater, potential of rainwater to be harvested. This can be done by studying the extent of terrace area, paved area, and the area with the top and the area which is open to sky, and using there are different infiltration and runoff coefficients which are available, which will help to determine the amount of water which will be storm water which will be generated from the terrace top, from the paved area, and how much water will get infiltrated. This helps us to design the recharge wells and storage tanks for the storm water, for the harvesting the rainwater. Now, then we have hazardous waste quantities. To assess the hazardous waste quantities, we have to first study the manufacturing process and study the stepwise material balance, utility requirements, and the effluent treatment processes. From this, we can compute the types and categories of hazardous waste as per the hazardous waste regulations of 2016, and then determine a plan for their safe disposal. Then we have municipal solid waste generation, which can also be easily computed from a mixed development, and based upon the area and estimating the population, and then plans made for their safe treatment and disposal. Similarly, traffic generated from new projects, large area projects like ports, mining, greenfield airports generate huge amounts of traffic. And this traffic, whether it can be effectively dispersed, whether there are sufficient roads available to disperse this traffic, can be estimated by guidelines which are available from the Indian Road Congress or the UDPFI. Now, although we have all these techniques available, these techniques can help us to only reduce the amount of impact which is generated from such projects, and only design the environmental protection measures or the pollution control devices in a scientific manner. However, we have to remember that landforms are formed over years of over centuries through various complex physico-chemical biological process, and are the base on which the ecosystem is established, and on which the life forms thrive. These processes we can never replicate. So, and we also should remember that land is a scarce resource, and we should take all steps to reduce impacts in all forms as much as possible. Keep the portion, if possible, try to keep the natural areas unaffected, and don't plan the projects in such a way that the impact on the land environment can be minimized. Now, looking at the stages at the air environment aspects, the aspects which we cover during project related studies are the manufacturing process, details of the manufacturing process, the types of air and noise emissions which are likely during various phases of the project. During baseline studies, we cover various aspects like sources of air, noise, pollution in the vicinity of the project, the meteorology in that area, topography of that area, existing ambient air and ambient noise quality, and based on this, now we have to go about the assessing the impacts from air and noise pollution. So first of all, we have to have a clear concept of what is air pollution. Air pollution is the deterioration of the Earth's atmosphere directly or indirectly as a result of human activities. Now, which are the degenerative actions which can cause impacts on air environment? Well, of course, the degenerative actions can be classified into various types. One is construction activity or mining, where again the major impact is due to the land clearance, land cutting, filling, etc. Where the types of sources are the excavation machineries, the operation of RMC plant, hot mix plant, crushers, etc. And the major pollution is from the particulates, dust, PM10 and PM2.5. Then we have manufacturing processes and plants like petrochemical plants and large iron and steel plants, mm, smelters, fertilizer plants, cement plants. So in case of petrochemical plants, we have major fugitive emissions, which are the volatile organic compounds, and resultant odors and the toxic gases which may be released into the atmosphere because of that. Sometimes we have process emissions like from ammonia, comprising ammonia, which is NH3 here, hydrogen chloride, hydrogen sulfide, chlorine, etc. And in the case of iron and steel plants, cement plants, etc., we have major pollution which is because of the particulates. In case of power generation, there is emission from fuel burning for power generation, and in utility boilers, heaters, etc., where there is increase in ground level concentration of primary pollutants like TPM, SO2, NOx, etc. Then we have traffic source, which results in particulate matter, sulfur dioxide, nitrogen oxides, hydrocarbons from vehicular traffic, which results in increasing the ground level concentration of primary pollutants like particulates, sulfur dioxide, and nitrogen oxides. And then there are some other area sources like, so we have point sources, which are basically from the manufacturing plants, power plants, etc. We have traffic, which are also called as the line sources, and the sources which are from construction, mining, or area sources like unpaved roads, waste dump fires, etc., are called as area sources, and these are major causes of particulates pollution. Now, when we assess the environmental impacts with respect to the air component, we have to look at the national ambient air quality standards, which have been issued by Ministry of Environment and Forest in 2009, which covers the primary air pollutants, 13 which covers primary air pollutants, that is SO2, NOx, particulate matter, PM10, PM2.5, and then the carbon monoxide and ammonia. And then we have some secondary pollutants like ozone and benzoapyrene. Now these are of course basics of particulate pollution. What are the sources of pollution? Particulate pollution, this is a particle which is 10 micrometer in size. If you compare it with a cross section of a human hair, you will see, notice the particulate matter PM10 is such a small particle, whereas the particulate matter 2.5 is even smaller than that. Of course, it's a subcomponent of PM10, which is basically generated, major amount of pollution which is generated, particulate pollution which is generated is the, and nowadays the most important or significant one is PM10 or PM2.5, because PM2.5 particles are the ones which are wholly generated from anthropogenic activities. PM10 particulates are the ones which can enter into your nasal stream and can clog your lungs, etc., or affect your respiratory system. But these are generated primarily from, these may be generated from activities like road dust resuspension. However, PM 2.5 are particles which are generated fully from anthropogenic activities. Now, what are the sources of these pollution? These include various type of combustion sources. PM 2.5 can be generated from combustion sources like motor vehicles, power plants, wood burning, industrial processes like iron and steel, chemical reactions, means like sulfate aerosols which are generated from due to excess sulfur dioxide emission into the atmosphere, and their reaction with the water in the atmosphere creates sulfate aerosols, which also are can be taken in the same size of PM 2.5. And the various high temperature industrial processes like smelters, steel mills, power plants, etc. All of these are causes of PM 2.5 pollution. Similarly, we have sources of dust and particulates, which include crushing or grinding operations, dust from paved or unpaved roads, construction and demolition waste, etc. Now, the health effects, of course, we all know this. They can enter into our respiratory system and cause cardiac failures, or even affect our lung function, cause lung cancer, or cause coughing, wheezing, shortening of breath, etc. Similarly, we have the other air pollutant sources like sulfur dioxide is generated from fuel burning in power plants, boilers, incinerators, etc. Nitrogen oxides are primarily generated in nitric acid plants and incinerators. Nitrogen oxides generally require high temperature processes because these are mostly generated from the nitrogen which is present in the atmosphere. Its reaction with the oxygen results in the formation of nitrogen oxides. Carbon monoxide is generated from incomplete fuel combustion. It is there in all the vehicular exhausts which we have. Ammonia is generated from municipal solid waste sites, landfills, industrial process vents, etc. Ozone is a secondary pollutant which is generated by the reaction of nitrogen oxides and volatile organic compounds. Uh, then we have lead, nickel, and arsenic, which are from metal refining activities. Lead is basically from the petrol fired vehicles. Now, how do you assess the impacts on the air environment from a particular project? The what we do is we have several prediction models which are used. So, if you know the project and its uh, nature and quantity of emissions, the landscape in which that project is located, the terrain in which it is located, the meteorology of that area, we can use these models to find out the increase in ground level concentration which will be caused because of these projects. The various models which are principally used are, one is the industrial source complex ISC3 model, which has which can take in inputs from point, area, and line sources and volume sources, and operates in both long term and short term modes. What it means is long term means over a full year or over a season, etc. Short term means 24 hours. As we have seen here, the standards for various pollutants are given on 24 hourly basis or on annual average basis. So if you want to compare the effects of a project's emissions on the ground level quality in the area, it will be you have to compare it against the standard, which is in terms of 24 hourly standard or the annual average standard. And therefore these models have modes for both long term and short term dispersion. A higher version of ISC3 model is the air mod, which is basically a Windows based software instead of the ISC3, which was a DOS based software earlier. And then we have a Kaline 3 model, where which is a model which is principally used for finding out or determining the impact on due to road or traffic or highway traffic, that is due to line sources. So there are various other models also available which can be used. Now, how do we use these prediction models? The models you require inputs like source details, that is the height of release, the flue gas quantity, temperature, velocity, and concentration of pollutants. Then they require the meteorological data of that area in terms of hourly data for wind speed, wind direction, temperature, and the stability. So we require four parameters. And then we have terrain features which are required, that is the elevation in the nearby vicinity of the project. And then based upon this, the model predicts the ground level concentration of the various pollutants in the 10-kilometer study area, and in a grid fashion, which can be extrapolated to form various isoplates to show, to connect the locations having similar impacts. And the modeling helps us to ensure that ambient air concentrations within the vicinity of a project are within the national ambient air quality standards. And it also helps to determine to decide that whether the stack height provided by the proponent is sufficient or we need to increase it. And also it may help us to determine the adequacy of the air pollution control equipment or plan for new air pollution control equipment based upon the levels of the ground level concentration or based upon the requirement of the scrutinizing agency or the expert appraisal committee. Now, these are the two outputs of a sulfur dioxide from a 15 tons per hour boiler, which is based upon furnace oil. And if you see here, the windrows of that area has been shown on the corner, which shows the wind blowing from which direction. So principally, the wind is blowing towards this direction. And we have in this particular area, we have a wildlife sanctuary very near to the project. Now, if you do the modeling without assuming that there is a simple plain terrain all around in 10-kilometer vicinity, this is the kind of plume which we get, and maximum impact which we get is about 0.8 or 1 microgram, 1.2 microgram in terms of sulfur dioxide levels. Whereas if you consider the topography, the levels which we get are seen here, where we can see that the various the based upon the topography of that area, the amount of the concentration of pollutants will change. Now, the other aspect which is covered also under air pollution is the noise levels. As we all know, noise is nothing but unwanted sound, and is generally measured between 20 hertz to 20 kilohertz. The major sources we all are aware: transportation system, industrial operations, which include chipping, forging, fiddling, construction activities like piling, blasting, drilling, boring, household noise or cultural noise, various cultural activities, festivals, concert halls. And what are the effects of noise? We are all aware of this. The health effects in terms of the high blood pressure, sleep loss, memory loss, inability to concentrate, and then the effects on fauna and avifauna. It scares away the fauna and avifauna, and And another offshoot of noise is the vibration and shock wave. It is basically generated in case of blasting near mining sites or near sites where a lot of land clearance activity is going on, where the blasting may affect the nearby buildings and structures. Now, how do you model the impacts from on the noise levels? There are, in fact, there is an Indian software which is available, which is the Dhwani Pro software, which can effectively model the noise levels from construction sites, traffic, and industrial activities. And the model is based upon ISO 9613, which and has various facilities for determining outdoor noise, attenuation, and for predicting noise due to road traffic. Now, again, the noise levels, predicted noise levels are superimposed over background noise levels, and resultant levels are compared with the standards under Environment Protection Act. This is a typical output which we have got for a chemical site in, I think it is in Khopoli area, where the impacts were from the site as from the manufacturing activities. They had a small captive power plant there, and there was a lot of road traffic which have been generated. So the impact, combined impact due to road traffic and captive power plant and various operation of various major machineries like compressors, blowers mm, was done, and we got a impact which shows the level of impact. The noise modeling helps the output from the noise model is then compared with the standards which are specified under the Environment Protection Act. And if there is any exceedance, then we can plan to have barriers, say along the road, in order, particularly near sensitive areas, like when we had done a study for expansion of National Highway 4, uh, uh, that is from Pune to Satara to Kagal, we had provided for uh, 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 buffers or barriers or berms all along the sensitive features. And then we had provided adequate, we can also plan for adequate noise protection at the source, means how we can reduce the noise generation from the source itself. Now, when we now we go to water pollution, assessing the impacts from with respect to the water environment aspects. Here, when we did this project related aspect study, we must have covered the manufacturing process details, the water requirement and sourcing, the liquid effluent generation during various phases. And during the baseline studies, we normally cover the sources of water pollution in the vicinity, sources of water and water pollution in the vicinity, then the topography and the drainage pattern, and then we assess what is the baseline ground and surface water quality at the and then now what our task is to assess the impacts to the water environment due to how to do that. That is our task. So for this, we should understand the concept of water pollution. Water pollution is the deterioration of the earth's hydrosphere directly or indirectly as a result of human activities. The degenerative actions which cause impacts on water environment uh, uh, are due to discharges from point sources and non-point sources. Now, point sources, as the word suggests, are the effluent discharges which come from manufacturing industries or wastewater treatment plants, that is common effluent treatment plants. As the name suggests, the point sources are easier to regulate because it's a single point source, and generally in the control of an industry where it is easier to regulate, whereas non-point sources are the ones which are diffuse sources, like water which is draining out of a construction site in all the direction depending upon the topography, or the water which is draining out from agricultural farms, etc. The storm water which is draining out of agricultural farms, which is containing pesticides or fertilizers, nutrients, which are causing pollution in the nearby water bodies. Now, these are the ones which are difficult to control because there is no single identifiable source. Now, impact of water pollution, we are more or less aware of this. This is the various types of contaminants can be grouped into organic pollutants, so particulates, suspended particulates, inorganics like metals, heavy metals, nutrients, dissolved solids, uh, and acidic or alkaline effluents. The sources of various polluting parameters have been identified here, and the impacts which these cause. This any EIA scientist should be fully aware of what are the likely sources of contaminants, and what are the impacts which may be caused because of these polluting parameters entering into the environment. For example, toxic organics or toxic metals may enter into food chains because of industrial discharges. Depletion of dissolved oxygen in waters is of course known to most of us. In case of suspended particulates, which results from mining activities, we may have siltation or reduction in light penetration, which results in fish kills. Nutrient discharges may result in algal blooms getting formed. Now, if to assess the impacts due to water pollution, there are two scenarios which are possible. One scenario is in case you have a discharge which is going to a CETP or a common effluent treatment plant through a public underground sewer or through a truck or a tanker, etc. In that case, the major focus of a EIA scientist should be to gauge the adequacy of the effluent treatment facilities which are planned by the proponent to meet the discharge standards which are set under the Environment Protection Act. Here, we should have clear concepts of how to segregate the waste and how to treat the various segregated waste in a proper manner so that the various discharge standards are met. Now, what are the standards which are propagated by the MOEFCC? A brief summary is given here. One is the discharge standards, general discharge standards for discharge of effluents, which are based upon the receiving water body, that is inland surface waters, public sewers, land for irrigation, and marine coastal areas. As an example, if you see the discharge, higher levels of pollutants are permitted into public sewers because it is assumed that they are going to be treated later. And if you are going to dispose of the same effluent on different receiving water body like a marine coastal area or in inland surface waters like a lake or a river body, then the BOD level goes down to 30 as against 100 in a marine coastal area. Now there are other standards which are given specified in the Environment Protection Act, which is the load based standards, concentration based standards, industry specific standards, or the State Pollution Control Board may itself specify more stringent standards. Now the other scenario is when the proponent is proposing to dispose of its effluent into the receiving water body, into a natural water body directly, that is through a pipeline. The effluent is to be discharged into either marine area, either into a stream, a river, or a estuarine portion of the river, or directly into the sea. Now, in this case, again, like what we saw in the case of air environment, there are different types of models which are available: one-dimensional models, two-dimensional models, three-dimensional models, which are available, and which need to be used in order to predict the impact on the natural water body. Now, in this case, the type of model used depends upon the complexity of the hydrological system which we are trying to evaluate. One-dimensional models may be based upon the flowing small streams, whereas for deeper, narrow estuarine, deeper estuarine or water bodies, it may be have to be done based upon the three-dimensional models. There are various uh, commercial softwares which are available like Mike 21 or Mike 31 or Qual 2K, which are used for I'm sorry. Uh, there are various commercial softwares like Mike 21, Mike 31, or Qual 2K, which are used for such impact prediction. Now, water quality modeling helps us to determine the quality modeling is, of course, a very complex task and is best done by professionals who are well aware of the subject. It involves various aspects like model development, model calibration, etc. What water molecule quality modeling again helps us to is to determine the final disposal point, because even if we say the disposal has to be into a sea or into a water body, where exactly into the sea or where exactly into the water body should the disposal be made so that the effluent gets dispersed very fast, and it will help us to determine the concentrations of effluents in the disposal pipeline, and determine the if additional effluent treatment is required. Uh, the In case of the predicted water quality which is there is then assessed on the with respect to the various standards in vogue. For surface water quality, we have the IS 2296, which is the surface water quality standards, which is based upon the designated best use of the water body. And or we may look at the coastal water quality criteria for discharges into estuarine systems or into open sea, where based upon the designated best use of that marine water body, whether it is SW1 class or a SW3 class water body, you can check whether the disposal location is appropriate as per the class of the water body where you want the discharge to happen. Now, the general rule of thumb in this case is that the at the disposal point, the dispersion should be so that so that the ambient water quality concentration is reached within 100 meters of the disposal point, or 150 times the dilution is available at the disposal point. Uh, Now we come to the biological environmental aspects. We have when we study the when we studied the project, we should study at various aspects like the area utilization of the project, the liquid and the solid air pollution generation from the project, or the waste treatment, waste generation from the project. Whereas in case of baseline studies, we should look at baseline ecological setting, topography, and presence of various eco-fragile features in the vicinity of the project. Now, the impacts due to project may be on the biological environment, may be direct or indirect impacts. This may be because of cutting of trees, clearing of land for vegetation, or changes in hydrology, like in case of irrigation projects, mining projects, etc. This may affect the vegetative cover of that area. Then we may have indirect impacts on flora and fauna due to pollution levels, or due to noise, excessive noise, which may scare away the avifauna. We may have introduction of alien species. For example, in golf courses, there are certain types of lawns which are planted in order to ensure that they can sustain for a longer duration. We have to ensure that these are not invasive, and they get adjusted to our environment and our area. Developments near seashore and estuarine water bodies are affected because of intertidal, which may affect the intertidal flora and fauna. We all know of the various the importance which the courts, the NGT has been, and the Ministry of Environment has been giving for the mangrove protection. Um, because as we all know, wetlands are a very important uh, biodiversity ecological feature, and they support a lot of flora and fauna, particularly avifauna. They are habitats for birds. They help in flood and erosion control. They help us to detoxify the waste products or the discharges of from the sewage, or the other discharges which go out into the sea. The threats which our wetlands are facing today are because of discharge of pollutants, over exploitation of natural resources, and uncontrolled siltation, weed infestation, and other anthropogenic features. Because as I mentioned some time back, the for waste disposal in Mumbai, there is no land available. So the MCGM has made a case to the MOEFCC that we want to dispose of our waste into the mangrove area and to the CRZ area along the eastern suburbs, and MOEFCC has granted a permission for this. Now, to assess the impacts on biological parameters, the ecologist in the EI team must ascertain the number of trees to be cut, of course, and the how many of them are well developed in terms of their age, their diameter, canopy size, and how many are indigenous species. Then we need to find out if there are any special species of conservation concern, and any trees which have nesting on them, and so that they can be marked for transplantation or cutting at a later date. The uh, master plan of the area should be well known to the ecologist, and the pollution potential of the project or the impacts due to the project on hydrology, hydrogeology also should be known to him. In case of benthic environment, the ecologist must study the benthic biomass quantity and determine the species diversity and abundance. But then, as we are all aware of projects where we hear of the environmental clearance being granted with conditions to plant five times the number of trees which are cut, or five times the number of mangroves which are cut. However, we have to remember one thing, that again, like as I mentioned, in case of land environment, the biological environment is a very complex environment, and we can never replicate the natural ecosystem fully. uh, we can only plant those many number of trees and hope that over time these new areas which are coming under vegetation will also develop into natural ecosystems similar to what were existing previously. Now, in terms of when we are to assess the impacts on the socio-economic environment, uh, again, let us briefly summarize what we have studied during the project related environmental aspects. Are one is the details of the development, the amount of investment which is going to be made, the amount of manpower which is going to be deployed for various phases, and the likely pollution from the unit. And from in terms of baseline, we can study the population distribution. We have studied the population distribution and vulnerable groups in that area, that is the tribals, the fishermen, etc., and their economic and health status, and the presence of sensitive features in that area. Now, our task is again to assess the impacts on the socio-economic environment. First, we should again understand what are the direct impacts of projects on socio-economic impact. The impacts of projects on socio-economic environment can be in two types. One is the direct impacts and the indirect impacts. Direct impacts are those which are obvious, like displacement of population, which is caused during highway projects or greenfield airport projects or port projects, industrial estate projects, etc., where the population will need to be rehabilitated, or those caused due to changes in hydrology or hydrogeology or drainage pattern, like in case of a irrigation project, where the flooding of the valley area may result in displacement of people. And there might be indirect effects on the health and socioeconomic status due to the increase in pollution levels. Again, as I mentioned, the knowledge of the vulnerable sections of the society and how they can be impacted due to the project is very much essential while trying to evaluate these portions. The aspects to be considered during socioeconomic impact assessment include the what are the are given in this slide, where we which are the questions we should ask, like Will the project development create new impacts or accelerate or cause secondary developments in that vicinity in the of the project? Uh, how whether the project's impacts would be adverse or beneficial, or what would be the impacts on the socio-economic and cultural aspects of the area. Uh, then quality of life is a term which has been used very much recently for determining how satisfied are the people with respect to the infrastructure, with respect to various um, infrastructure and other facilities in the vicinity. Like this quality of life is computed based upon surveys of individuals, and where we use different indicators, different 16 different types of indicators. A level of a score of high, one is given in case of highly satisfied, and from the there are two objective and subjective quality of life determinant parameters which are determined, and the cumulative quality of life is determined as the quality subjective quality of life plus quality objective quality of life divided by 2. These are the detailed computations. Now we have seen the impacts due to individual on the individual environmental components, that is impacts on land, air, environment, water, socio-economic and biological. We now are at a stage where we should be doing a summary of the environmental impacts in order to look at the whole picture and identify which are the crucial points where we need to attack and focus in order to develop the management plan in a proper manner. Now, what are the techniques which are available for doing such a summary? There are three techniques which are principally used, which are used to map the environmental consequences of various developmental projects. One is the checklist method, which is the then we have a matrix method, which is the Leopold method, and the battle evaluation and assessment system, battle environmental evaluation system, BEES as it is called. The checklist method is a very simple method, which wherein we write the activities on the left of the site and uh, uh, the extent of impact which is likely on the activities are listed on the in the column to the left, whereas the during the type of impact which is there, like adverse impact, no impact, positive impact, is written towards the on the right in the rows. And very simply, in a very simple checklist, what we do is only mark the box with a cross or a tick mark to identify to based upon the judgment which we are having for that particular project. Like in the construction phase, naturally any project will result in reduction of open space. So if you see on the left, we have marked a tick cross there to indicate that there is a negative impact which is created on the open space availability due to the during the construction phase. There are some when where wherever we have marked it as cross or a tick, it indicates that there is an impact, but the blank boxes indicate that there is no impact. Now the problem with the now this checklist, the simple checklist was later on evolved to be made more informative. And see, for example, the one on the right is breaking up the activities during construction phase into various small components like site clearance, earth moving, laying foundations, material receipt and transport, cumulative impacts, etc. And the environmental parameters are mentioned on the left, where again the tick mark is indicating that this particular component has been impacted. But but the simple checklist had a problem, that is the severity of the impacts cannot be gauged. It is only indicating that there is an impact, whether it is a high impact, low impact, etc., cannot be gauged. So uh, these techniques were later on modified and have been used even today, where we have a scaling checklist where we can rank the level of impact on a scale of say 5, where 5 indicates high impact and 1 indicates low impact. So again, the impacting actions are given in the row on the top, and the physical and environmental components are given in the column to the left, and the marking is made on the various in the various boxes accordingly. Now, uh, but as I mentioned, since this checklist system does not really give an idea of the magnitude of impact, other methods which were developed. One was the matrix method, which is the most common one, which was used is the Leopold matrix. In this case, the the severity of the impact is given. In this case, as you can see, the box is split into two parts by a diagonal, wherein the magnitude of the impact and the significance of impact is both marked in scales. Like magnitude may be marked ranked from a scale of -10 to +10, and the importance of that particular parameter in may be given in terms of 1 to 10 rank. Now this uh, this is a typical Leopold matrix which has been developed for a particular project, where we can see the magnitude as well as the significance having been marked on that particular site, and the net or the total overall impact of say blasting or drilling operation on various aspects like soil, etc. So the impact of the overall project and its significance can be ascertained from this particular checklist, and also the impacts. So we can take a total of this to determine what is the impact overall of these parameters. Now, this is a good technique which was used quite. It was originally developed by by Leopold, and it is a very flexible technique. We can change the number of parameters or the number of uh, uh, the activities which can create impacts. Now the other technique, which is a more advanced technique, is the battle evaluation, environmental evaluation system. In this system, the classification consists of 4 levels. One is the categories, second is components, parameters, and measurements. So each category is divided into several components, each component into several parameters, each parameter into one or more measurements, and the EES has identifies a total of 4 categories, 18 components, 78 parameters, and a numerical value is assigned to each attribute based upon certain weightages, and these weightages are termed as parameter importance units. This is the how a total weightage matrix is evolved. We can see here the categories which are given, that is ecology, which has sub components, that is species and populations, habitats and communities, and ecosystems, in which again various parameters are identified to properly describe the each of these components. And then a parameter importance unit a score rank a score is given for each of these components. A overall score for that component is determined, and based on this, a total weight of 240 has been determined for ecology component by this particular team for this particular project. It is all dependent upon the project. It is all dependent upon the site. So the EI team has to sit together and decide that in this particular project, what is the weightage to be given, and how this distribution of this 1000, the total has to come to 1000 for all the various categories, and the EI team has to sit and decide what will be the total which will come. Now, based on this, after the evaluation matrix is decided, the EI team decides to then scores the various components for the particular project and gives an environmental quality score. Now, the environmental quality, the scale of environmental quality score is given here, which is from 1 to 0.1, which is 1 means excellent and 0.1 means unacceptable. So, based upon their rating of the project planning or the project in terms of they rank the various components, and then the environmental quality index is then computed. The environmental quality index is derived as from the formula of environmental quality score multiplied by the PIU, and a quality score index of 0 to 25 indicates poor environmental ranking, whereas a quality index of 76 to 100 determines excellent environmental ranking. Now, to environmental so we what we do is, after this is done, there are two the study this battle environmental impact evaluation system is applied with two scenarios. One is with the project and the other is without the project. Now, the difference between the two scores is a measure of the environmental impact which is there. And for example, on a scale of 10, if the project if the score before the project was 9 and after is 2, it means a high impact. However, if it was 9 and after project it's 7, so the impact is low. So this is the way you can come to some conclusions about the overall scale, overall environmental impact of the project, and or tighten the environmental protection measures, tighten the environmental mitigation measures in order to ensure that the impact goes from high to low. Now, therefore, what we need to do is to determine to consolidate and summarize the impacts of each environmental components, arrive at a weighted score with and without the mitigation measures, and come to a final conclusion of the net impact of the project. This helps the coordinator or the chief to convince the proponent of the need to take up suitable measures and to ensure that the impacts on those environmental components can be reduced. So, uh, thank you all for a very patient hearing, and I will of course be coming to you for any if you have any doubts, you may make a note of them, and I will certainly be happy to reply to your queries. Uh, Environmental impact, as you have seen from the discussion above, environmental impact assessment or assessment of an impact is a very difficult and a very multidisciplinary job task, because it requires knowledge of various physicochemical, biological and other factors, and also a knowledge of a lot of engineering aspects which we have seen. So uh, a very mature team is required in order to study the projects, understand it fully, understand the situation in which that project is located, the locale in which that project is located, in order to come to a proper final conclusion of what is the extent of impact. So thank you.